All right, sixth graders, we are taking our next page of notes, and we have now finished up the unit on fraction operations. So we've added fractions, we've subtracted fractions, we've multiplied them, and we've divided them. And today we're going to be working, so we're not leaving fractions behind, but we are moving on to a new unit, and we're going to be working with fractions to decimals. So we're going to be working on changing fractions into decimals and vice versa. And actually, as a general rule, and you don't have to write this down, but I do just want to show you, as a general rule, that fractions and decimals and percents are all related to one another. So again, you don't have to write this down, but we're just going to talk through it very quickly. So maybe you have seen a 10 by 10 grid. You probably did these when you were in elementary school, so it looks something like this. 2, 3, 4, 5, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So something like this. A 10 by 10 grid, so if we count it up the side, there's 10, across 10, which means that there's 100 total squares here. And so one of the things in elementary school that you work on is thinking about pieces of this 10s grid. So if I were to take my highlighter here, and if I were just to highlight a whole row, of course that would be 10 out of 100. If I were to do the second sort of column here, that's going to be 20. And then if I were to 1, 2, 3, 4, 5, if I were to shade in 5, of course that would be 25. And so again, somewhere in elementary school, you learned that you could represent this picture as both a fraction, decimal, and a percent. So as a fraction, we would think, okay, there's 25 of these squares shaded, 25, out of a total of how many? There, out of 100, and 25 over 100. If we think about quarters, that's also the same thing as the fraction 1/4. We could also simplify that by 25. So as a fraction, this shading or this picture represents 25 out of 100 or 1/4. Now as a decimal, we could represent the same thing, because it is out of 100. We can count how many hundredths there are, and so remember your decimal to the second place. Remember, this is your tenths place. So we have 2 tenths and we have 5 hundredths. ETHS. And so we could also represent this picture as the decimal 0.25, or we would say this as 25 hundredths. We could pronounce that using that last decimal place. And then as a percent, well, the actual word percent just means out of 100. And so what we can do is we can also write this as 25% of the square is shaded in. And so we get this idea that fractions and decimals and percents are all ways of representing the same amount, the same image, the same piece of a whole, but it's just different ways of writing it. So 1/4 and 0.25 and 25% are all representing the same thing. And so what we're going to work on over this next unit is going between these. And again, you didn't have to write all that down. You might want to take a screenshot of it though, so you'll have it for later. But again, what we're going to work on over the next couple of weeks is translating between the two. So if you think, you can almost think about fractions, decimals, and percents as different languages, but they're all saying the same thing. So we could say hello, we could say hola, and we could say bonjour in Spanish and French and English, but they would all mean the same thing. They all mean hello. And so again, fractions, decimals, and percents are just kind of like different languages of representing the same thing. So today, of course, we've already written our title, and today we're going to focus on going from fractions to decimals. Now, we're going to go from decimals to percents and percents back to fractions and percent. We're going to go between them all, but today we're just going to focus on this one thing, fractions into decimals. All right, so we're going to see that picture again. But let's go ahead and write down, how do we change a fraction to a decimal? So here's a definition for you to write down. We need to first say that all fractions have an equivalent decimal. So every single fraction that you know also has a decimal that's equal to it. Equivalent is just a fancy way of saying equal. And so we're going to look at a couple different methods. There's actually 3 different methods for changing or translating a fraction into its equivalent decimal. And so method number one is using the place value. So again, if we think about place value in a decimal, if you think about just a decimal in general, so think about having a decimal here, and sometimes, you know, there's a number out there in front. This next place value here is, of course, called the tenths. The place value after that is hundredths. The place value after that is thousandths. After that, it's 10,000ths. So on and so forth. Again, hopefully you remember this from elementary school. We could even go further than that and say 100,000ths. And we're going to stop right there because that's about as far as we'll ever have to go. So just remembering your place value from elementary school, we can look at an example. So example number 1. And let's look at 3/10. So 3/10 is our fraction. We're starting with our fraction. We want to write it as a decimal. Well, because the denominator matches with one of these words, so I do have tenths, all right? If this had been 100, I would be able to do it. If I know that this denominator is one of these place values, then all I have to do is write down a 0 point and then the numerator in that place value. So tenth, again, we would say this out loud, 3/10, because tenths is the very first place value after the decimal. We could also say this as 3/10. It's in the tenths place. And so if we place it, if we drop our numerator 3 into the tenths column, it matches with our fraction. So let's look at one similar to that. So example number 2, we'll put it over here. If you have 27 out of 100, we could also say this as 27 hundredths. How could we write this as a decimal? Well, we'd write 0 point because it's not a whole yet, it's still a fraction. And now my denominator is 100. Well, I know that hundredths are 2 decimal places, and my numerator actually has 2 place values. So I want to put the 2 in the tenths place, but I want to put 7 in the hundredths place. And so I would read this as 27 hundredths because it goes out to the second place value. So again, I'm just writing the numerator after the decimal. Now this can get a little trickier when you maybe have extra digits. So let's do one that maybe is a little bigger than that. So 157, and let's do it over 1, 2, 3, 4. Let's do it over 10,000. All right, so we have 157 over 10,000. And so again, I want to look at my denominator and say, okay, 10,000, where do the 10,000s go to? Well, that's 10,000 is 4 decimal places. So again, it's not quite a whole. I'm going to put 0 point, but now I need 4 decimals because it goes all the way out to the 10,000s. Now the last digit should be in the 10,000. So I'm going to put the 7 in the 10,000s. I'm going to put the 5 in the thousands. I'm going to put the 1 in the hundredths. But notice I run out of numbers to put in the tenths. So I'm actually, in order to make it 4, I'm actually going to put a 0 and then 157, ensuring that my 7 is in the 10,000th spot. That last decimal, or that last digit is in that decimal spot in the 10,000th place. So sometimes you may have to add an extra decimal in there. That was example 3, by the way. And let's do one more example. I kind of went below the line here, but I'm going to squeeze it in. So example number 4, as far as place value goes, what if I had 53 3 over 1,000. So 53 over 1,000, 1,000 looks like the third decimal place. So thousandths are going to go in the third. That means that 3 needs to go in the thousandths. 5 is going to go in the hundredths. But again, I'm going to have to put a 0 in to make it stretch out far enough to go into the thousands. So we'd write this as 0.053 to ensure, again, that the 3 matches up with the denominator thousandths. All right? So that is one way of changing a fraction into a decimal. All right. And that only works, though, I hope you can tell, that only works if your bottom number, your denominator, is a 10, 100, 1,000, 10,000, 100,000, or I guess we could go up to 1,000,000, but you're not going to see anything more than that. So let's look at method number 2, which is we're going to change our denominator into a 10, a 100, a 1,000, etc. Okay, so if it's not already one of these, 10, 100, 1,000, 10,000, then we can change it into. And so just as a note, this works for numbers like 2, 4, it works for 5, it works for 20, it works for 25, it works for 50, but not much else outside of that. So we'll do a third method here in just a second where we eventually have to deal with what if we had a denominator of 3 or 6 or 7. But this method is going to work for these particular denominators. And so let's just look at an example. So example number, I guess this is example number 5. If we had the fraction 2/5. So we look at 2/5. So again, we ask ourselves first, can we just use place value to just, plop the numerator in? But in this case, we do not have a 10 on the bottom of the denominator. So I'm going to look for a way to change the denominator into a 10, a 100, a 1,000. And 5 is a nice number because we actually can change it into a 10. And I would multiply that by 2 on the bottom. So 5 times 2 gives me 10, and that's good because we know how to write tenths as decimals. But if I multiply the bottom by 2, I also have to multiply the top by 2. So 2/5 is the same thing as 4/10, which means if I write it as a decimal, I would just put the 4 in the tenths place. And so the tenths place is the very first decimal place after the decimal. So 0.4 for 2/5. Now, these of course can get a little more exciting. So let's look at an example 2, maybe of 8/25. So if I have 8/25, I look at 25 and I think, okay, 25 is not a place value. And I don't know how to change a 25 into a 10 by multiplying. You can't do 25 times something to get 10. So we have to think about the next place value up, which is hundredths. So is there a way for me to change a 25 into 100? Well, yeah, thinking about quarters makes it really nice because, yeah, if I have 4 quarters, I do get $1. So 25 times 4 gives me 100. If I multiply, and that's good because we now have 100 in the denominator. If I multiply the top by 4 as well, because I did that to the bottom, that's 32 on the top. And I know how to write hundredths as decimals. So hundredths is the second decimal, which means I want to make sure that I have 2, and my numerator does have 2 decimal places, so 0.32 is going to be the decimal for 8/25. Let me give you a couple to try. So I want you to try, we'll do example number 6 and example number 7. So example number 6, see if you can figure out what would the decimal be for 4/5 and what would the decimal be for 7/20. So go ahead and write that down, maybe pause the video, and then you can turn it back on and get it checked. All right, I hope you took the time to make sure that you were able to find the decimal. So let's look at 4/5. So 4/5, again, we have to ask ourselves, which one of these would we like to change a 5 into? And of course, we can change a 5 into 10. It's very similar to this one. We know that to change it into 10, we multiply by 2, which means I get 8 on the top. And so as a decimal, 4/5 is the same thing as 0.8. Example number 7, we get 7/20. 20 cannot be multiplied by something to get 100, or to get 10, but we can make it a 100. Actually, it's 20 times 5 gives me 100. And so I'm going to multiply the top by 5 as well. 7 times 5 is 35. And as a decimal, that's going to be 0.35 because hundredths have 2 decimal places. So if you know that your bottom number is a 10, 100, 10,000, 1,000, or you can use place value to write your decimal, that's method 1. Method 2, of course, was we didn't have a 10, 100, but we did have numbers that we could change into tens or 100s or 1,000s. And so last but not least, method number 3 is what happens when you have any other denominator. So this is going to, and I'll make a note down here in the line below before I write what it actually is. This is going to work always. This method always works. This method would work for all of these denominators, but especially for denominators like 3 and 6 and 7 and 8 and 9 and 11 and 12, etc. Especially for denominators like this, the method is very simple. It's to divide. Because here's what we know about fractions. If you think about a fraction is a number over another number, that symbol right there in the middle means division. Right? A fraction by definition is something that has been divided up into a lot of pieces. And so when we see something like that, we are going to divide when I see a fraction. So example number 8, we're going to look at a fraction. Let's look at 5/8. 5/8. Actually, I take that back. Sorry, erase that. Let's do 5/8 here in just a second. Let's start with one that we actually would be able to know first. So let's start with 3/5, which 5 is a number that we could, of course, multiply by 2 to get 10. And so actually, if we did it just the very shortcut way and we multiplied by 2, we would get 6/10. So we know that the decimal is 0.6, but I want to show you how division works to get 0.6 as well. All right, so we're going to divide, and I'm going to use the space down here. Actually, it would be probably helpful to split your page in half because we're going to do another one over here. So 3/5, we're going to write out our division bar. And again, we're dividing here. So what is it that's being divided? It's 3 divided by 5. So 3 is going to go inside the division bar. 5 is going to go on the outside. The bottom number always goes on the outside. And we ask ourselves, how many times does 5 go into 3? Well, we say, well, 5 does not go into 3 at all. So I put a 0. And 0, remember the steps for dividing are to divide and then multiply. So 0 times 5 is 0. Then we subtract. 3 minus 0 is 3 again, and I kind of get stuck in this loop. But what we know is that there's actually a decimal at the end of 3, and we can actually add a 0. So 3.0 is the same thing as 3, but because I'm going to add that decimal and add that 0, I'm able to bring down a 0 here, and now I have 30. What you have to remember to do as well is if you add a decimal into the number that you're dividing, you also add a decimal straight up in the air above your division mark. And so now we can do division again, but 5 goes into 36 times. And so 6 times 5 gives me 30. All right, so let's do one more example together. So example number 9, we're going to look at, here's where we're going to do the 5/8. All right, so we look at 5/8, and really the reason we have to know how to divide here is because 8 is not a 10, and nor can it be multiplied to be a 10, or 100 for that matter. And so we're going to divide 5 by 8. So we're going to draw out our division bar. The top number, again, always goes inside. Bottom number goes on the outside. And we start asking ourselves, how many times will 8 go into 5? Well, 8 is bigger than 5. 8 does not fit inside 5, so 8 goes into 5 0 times. 0 times 8 is 0. Subtract. 5 minus 0 is 5. We're stuck, so we have to add a decimal and a 0 after our whole number and bring down the 0. Now we can ask ourselves, how many times does 8 go into 50? 8 goes into 50 6 times. Now don't forget to bring your decimal once you've added it here, also add it in your answer. So 8 goes into 50 6 times because 6 times 8 is 48. We're going to subtract that. 50 minus 48 gives me 2. You might have had to borrow if you were doing it one column at a time. We're still not done. The way we know that we're done right here is that things come out evenly. So notice over here, 30 minus 30 actually came out to be 0 as a remainder. So 10 minus 8 is 2. We still have a remainder, so we're going to add another 0, and we're going to bring down our 0 to make this 20. So now 8 goes into 20 2 times. 2 times 8 is 16. Subtract. 20 minus 16 is 4. We still haven't got a 0, so I'm going to add another 0 and bring it down. That gives me 40. And 8 goes into 40, actually evenly, 5 times. 5 times 8 is 40. And I do end up, here's how I know that I'm done. I get a 0 remainder. And so the decimal equivalent for 5/8 is 0.625. Now I want to point out one last thing, and again, you don't have to write this down, you can just watch it. One last thing is what happens if we had a decimal like 1/9? So notice I'm going to set this up similarly. 9 does not go into 1, it goes in 0 times, and we bring down our 1, so we have to add our decimal and our 0. Bring down the 0. 9 goes into 10 one time. I'm going to bring up, make sure you bring up that decimal. Goes in 1 time because 1 times 9 is 9. When we subtract, 10 minus 9 gives me 1 again. And so when I go to add another 0 and bring that down, I'm sort of stuck in a cycle here because I just asked myself a minute ago, how many times does 9 go into 10? It goes in 1 time, and 1 times 9 is 9. Subtract, you get 1. Add another 0. Bring down the 0. It's another 10. So how long could we do this process? We could be doing this process all day long because notice it just repeats itself. And so when you get into a pattern of a repeat, what we call a repeating decimal, because you're having the same thing happen over and over again, what we can actually do is once we recognize that it's repeating, we can actually say this is 0 point. What is it that's repeating? It's the 1. And I put this special symbol of a hat on top of it. It's actually just a line. We would read this as 0.1 repeating. This symbol right here indicates that it's repeating. So if you start dividing and you get something like 0.25, 25, 25, 25 over and over again and it just gets stuck, you can actually write that as 0.25 repeating with a hat on it. Something similar happens with 2/3. If you divide out 2/3, it's 0.666, on and on and on. You can actually just write that as 0.6 repeating. All right, so there's going to be some practice problems on that you're going to practice. You're going to practice either with method 1, if it's a 10, multiple of 10 on the bottom. If you can change it into a 10, awesome. Or the final practice, the final way you're going to practice is just divide it out as a decimal. Good luck, and let me know if you have questions.